Welcome back everyone to Data Science for Everyone. Today we're going to be looking at natural language processing with Scikit-Learn and the SMS spam dataset. Let's get started. So first thing that we need to do is do a little bit of preamble work here, is make sure and import NLTK, so that's the natural language processing package in Python. We need to make sure and import it, and again, if this is on your own machine, make sure and install it. And then there's going to be, we're going to have to download some necessary data sets. Okay, so from NLTK, here we do download, and shift enter, and now it's going to ask us, for example, what do we want to download in here, and we type in all, and hit that. Well, we hit D, sorry, for download, and then the identifier that we want is all. So, and this may take a little while. This is going to install all of the corpora and packages that we want. You can also use this L in here to list out all the package if you don't want to install everything. But for today, I'm just going to show you guys how to install all of it, because again, if you guys are doing this on your own computer, you probably want to download everything once so that you don't have to do it again. I'm going to speed this up right now so that we don't waste too much time. So once this is all done, you can actually go through, and right now I'm in the configuration setup, so we can actually take a look at the configurations if we want to, but I'm going to go back to the main menu, and we're going to do Q for quit in here, and whoops, Q for quit, and then that will break you out of the installation so that everything is good to go. So as I said before, we're going to be using the SMS dataset, spam dataset in here, and let's go on and download the data. So we'll use curl, and I'm going to put this into the SMS spam collection .zip, and we'll let that download really quickly. And then again, once it's done downloading, we want to unzip the data. Zip, and I'm just gonna unzip it. Let's see, what do I want to actually do? Let me put it here, and yeah, I'll just unzip everything here so we can take a look at what variables there are. So we have this sample data, which is a small subset of the data. We still have our zip, the readme file, but this is actually the collection that we want. Let's take a look and see what format that this data is in. Let's look at head, SMS spam collection, SMS spam, there it is. And so if we look here, we see that this data does not have a header at all, okay? And also, my best guess is that this is a tab separated value, so this is going to be a TSV file. So when we go about importing this, let's go through and make sure that we get everything that we need. So let's do import pandas as PD, import numpy as np, import seaborn as SNS, import matplot libpyplot as plt, and then let's do matplot lib inline, and just these are just our standards. So let's go on and pull in that data. So let's call this SMS, or you know what, maybe we'll just call this a data frame for now, and do pd.read csv in here, and we want SMS, what was that file called? We'll just copy this, SMS spam collection. Now we need to make sure and do the separator in here, whoops, the separator in here needs to be a tab, so that's a backslash with a T, and then we also want to give in some names in here, and so we need, so if we look here, we have, for example, this here is our label, and then we also want in here a message or a text. So you know what, let's do message, no, we'll do text in here. And so let's go on and make sure that that actually looks right. Okay, so notice here we have a label, we have our text in here, and everything is looking okay. Let's also go through and start maybe some basic exploratory data analysis. So let me put in a note in here, and this is going to be to start EDA. So we have sms.describe. Whoops, what did I actually name it? DF, I forgot. Okay. Okay, so we have full observations. We have 2 unique. We have 5,169 unique values. So again, that means that there probably are some repeats in there. Again, something like K, okay, bye, something like that as well. So let's go on and separate this out, because we do have, if we look up here, we have ham, meaning a non-spam item, and then we also have spam for a spam text message. This would also work if you're using this for email classification or anything else. So let's go on and do messages. Oh, not messages. We want df.groupBy in here, and we're going to group by the label. And then we want to do our describe as well. And take a look. So again, here, notice that this is actually a pretty unbalanced data set. We have a majority are ham and less so are spam. And again, I'm kind of hoping that that's the case. Again, depending on your email. Ooh, bless me. Sorry. All right, so let's also maybe look at doing something like df.count plot in here, and we want here label, and we'll have our datas to df. Whoops, it's because I'm SNS. There we go. And so again, we can also have a nice visualization there, seeing that, again, it is a majority of ham. So another thing that we're going to need to do is start to do some feature engineering in here. Again, some things that we want to do in here is to have the length of the message. Okay, so how long is the text message? That type of thing, or maybe later on if you guys are doing tweets or something, how long's the tweet, how long's the email, etc. So let's go on and do call this length in here, and we want df text, and we want to apply in here the length function. Okay, and maybe I can show you guys an example before. Whoops. Before we do this. So if I do df text 0. Okay, so you can see here, go until Jurong Point, crazy, available only in blah, 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 blah. Okay, so if we want to take and we want to see how long this string is, we can do length onside this, and it will tell us that it's 111 characters. So let's go on and run this. Oh, whoops. And so we can actually go on and take a look. So now we can see here, again, that one wound up being 111 characters, and we went through and grabbed the length of each of them. Let's go on and also take a look at the histogram for that particular item. So let's do what? SNS dot displot, and we'll do this on length, and we'll do data is equal to our df. Oops, and it's dist plot. Oh, and what happened in here? Let me actually just delete this. Hold on, what happened in here? All right, let me cut this all out. SNS dot dist plot, and this takes in, okay, we can just do df length in this case, and let's have our bins equal to 50. Okay, and we see here that, well, this is going to be depreciated. So what does it actually want me to do is displot. Okay, so I will go back to displot. Okay, so we can see here that this is definitely skewed. Okay, a majority of these text messages are pretty long. Okay, and then they kind of peter out. Again, apparently we have some really long text messages in here, which I find is kind of strange. So let's maybe actually go through and look at the length variable a little bit and see what exactly is going on. And again, my fingers are not wanting to work today, are they? Okay, so this is our count. Our mean is around 80, so that's what this bad boy is probably around here, somewhere around 80. 80s, yeah, somewhere around here. Our maximum is 910 characters, so some of those are pretty long. Let's actually see what's going on with this maximum value in here. A minimum's a 2, so probably something like okay. But let's take a look at that first message. So let's do data frame, and we want what? Length is equal to 910. And let's go on and grab in here the text. And let's print this. Oh, no, I want it in a different way. Let's go through and do, what's a better way to do this? Let's do text.iloc of 0. All right, so this is the whole text in here, and maybe let me print it out so that we can see it. No, I don't like it like that. But we can kind of see it here. So again, here it basically looks like they're writing maybe a love poem or something like that, nice and long. So that's fine. But again, let's maybe see something. Maybe there's a distinguishing features between spam and ham, because again, I don't think that this particular one is a spam feature, but it is kind of interesting to see these nice texts. You know what? Maybe let's look at one more. Okay, and let's look at those that were at 2. So see, and again, it is okay. So let's go on and maybe take a look then at what do we want to see here? All right, let's separate them out by label. So I can go on and I can grab this, put this down here, and then we can do something like hue by label. Oh, does this one not have hue? I forgot about that. No, it does have hue. Oh, okay, so hue here, and let's do df label. It's still not gonna like it. Oh, because it's white. Okay, so then let's just do it with just the plot mechanism here. Histogram. We want our column here to be length. We want this to be by our label. We want our bins here to be, we had 50 before. And then let's change our figure size here to be something like 12 by 6. And let's see what we have here. All right, so then we definitely see that there's a definite distribution here that we can see. Ham has a tendency to be very, very short in nature. So non-spam is very short in nature. Now spam features tend to be on the long end, quite long. So around 150, okay, for their average, maybe a little bit more than that, 170. So again, this tells us that length is definitely going to be useful when we're doing some sort of prediction analysis. So we're going to have to keep that in mind. So let's go on and start our actual textual analysis and our text preprocessing. So text preprocessing, we're going to need to grab a couple things. So the first thing we want to grab is some from NLTK here, the corpus. We want to import stop words. So stop words are actually again something that's like very commonly used. So I, me, my, we, are, is. So let's actually maybe instead of me talking about them, let's actually take a look at them. So we want the words. We want to make sure that we are looking at English. And this, there are multiple languages. Okay, so then don't if you want to do natural language processing in maybe another language or something, feel free to. Okay, there are several. I've even done textual analysis in Chinese before. So again, those are all available to you. So here we can see here that this is the first 20 of the stop words. And so we have, again, these are all, for example, pronouns or something like that. But let's also look and see, for example, how many stop words there are. So here we have, it has just 179. You can also, probably won't do anything about that today, but we can do something like add in our own stop words or something like that. Again, once you start doing your own higher level pre-processing, maybe you have a specialized data set that you use for your company or something. So another thing that we actually need to go on and do is actually make a bit of a function here to pre-process the data. So our goal would be, for example, is to remove punctuation. And so let's go on and actually talk about how we would also remove punctuation. So I'm going to put this up here actually and say import string. So stop words, let me actually have that example, full example up, so you guys can still look at that. And 0 through, let's do 10 for now. Okay, so then you can see the whole thing. Now, another thing that we have is from the string package, we have punctuation. Okay, and so here you can see here, this is all the punctuation that we would wind up having. We need to also remove punctuation. Okay, so we want all of the periods, the dollar signs, the percent signs, all of that stuff needs to be removed. Okay, so let's go on and make a function that actually removes the punctuation, and it maybe does some text pre-processing. Now, as I've talked about before, okay, when you're going to be reusing something a lot, particularly with text processing and those types of things, always make a function. Remember to keep things dry. Okay, dry. Okay, that means here is don't repeat yourself. Okay, so the cardinal rule is if you do it 2 times or more, make a function. Okay, and so again, this type of function, particularly when we're doing this text pre-processing, getting out stop words, getting out punctuation, you're going to do it every time. So you might as well create a function for it. And then that way, all you have to do to add special stop words or add special punctuation or something that you want to remove is very, very easy to do by updating the function. So let's call this text processing. And this will take in some text in here. And you know what? I'm not going to use text. I'm going to say, yeah, text will be fine. And so let's see here. What do we want it to do? We want to remove punctuation. Now, I'm not going to do this I'm not going to make up a full documentation on this. I would go back and do that later on. So here, let's do a character for character in the text if the character is not in string punctuation. So here, this is using a list comprehension in order to do this. You can also do it in in loops if you so choose, but I personally prefer to use this punctuation, or this list comprehension. Next thing we need to do though is actually to join them together, because this actually puts them into a list. Join them together in here, and so we will overwrite this remove punctuation, and we'll do something like we want it separated by nothing here, and we'll do dot join remove punctuation. And then the next thing that we would want to do here is remove stop words. And so here we would want to make a return statement, and we'll say word for word in our remove punctuation dot split if word dot lower not in stop words dot words. Let me get rid of that here, and we want English. So let's go on and actually let's take a look at our original data frame really quickly, and let's do something like df.head here, and you can see here that our text has all of this. Okay, so they're all looks pretty long. Now there are some issues with this. You can see here that there's a lot of text speak, that type of stuff. So you may have to have specialized processors for that, just to kind of give you an idea. Now let's take a look here at our text messages here. Dot apply our text processing. I probably should have done that on a subset, but it's okay. It'll take it just a minute here to run. So you can see here that it split everything into these tokenizations. Tokenization in this instance is it's split it up by its name. Okay, now there are several pre-built models and stuff that you can do this as well from the NLTK package. There's even some other packages as well that you can use. But sometimes it's best just to be able to write your own to be able to control the process. So here we can see that it tokenized everything for us. So we also need to do some normalization in here as well. So normalization again is for example this you done say something like that, and you for example needs to be YOU. Those types of things. There are several ways to normalize, and you can do something such as stemming the data using parts of speech. We're not going to cover that in depth today. Okay, this is just kind of a basic introduction to things. We'll maybe do that in another video. We also then need to do, for example, some vectorization. So vectorization in this way can do counts. We can weight the counts. We can also normalize the vector units, and this is again making using a count vectorizer. So let's actually go on and do this. Okay, so let's go on and use do the vectorization process here. So from ScikitLearn dot feature extraction dot text import the count vectorizer, and we'll create a transformer. And this is actually from a bag of words. Okay, so a bag of words is thinking about you have everything, all your words in a bag, and you kind of just go and pull out and take this, and that's how you're going to be counting them. So we'll initialize our count vectorizer, and you know what? I may say CV transformer for count vectorizer. The analyzer we're actually going to use in here is going to be our text preprocessing. And again, you can use some of the built-ins as well. Then we're going to fit this on our data frame, and we want our text. Oops. Why did it not like my preprocessing? Let's take a look here. Hold on just one second. Let me see what happened. Whoops, so I was being a little silly here. I wound up filling in this instead of text. I actually wound up filling it with text preprocessing, thinking about our preprocessor. So let's go on and, whoops, let that run for a second while I fix this. In here. All right, and so let's actually take a look at, now notice we did this in two ways. We actually initialized and did our fit in one. Okay, some people like to do them in two stands, but that's okay. We can just do it all in one. So let's actually take a look at how big our vocabulary actually is now. So print, I don't actually need that. We need the length of our CV transformer dot, and here we want our vocabulary, and grab the vocabulary with an underscore. And so here you can see that this is actually pretty big. We have 11,425 words. And then so let's actually go on and take a look at, for example, what would happen with some of our messages. And look at what would happen if we transformed maybe a specific line for our bag of words. So let's go through and see about what do we want? Text 1. So we'll still grab, I'll say text 0 because we grabbed that first text message to look at it before. Let's do df text, and we want 0. So text 0, this is that go until blah, blah, blah. And so then let's actually use that count vectorizer to transform the data. And let's do, we'll call this our bag of words 0 here. And we want our CV transformer here. And we want to throw in, our text 0. Oh, whoops. And we need to put this actually needs to be in a list. Because again, it has this expectation that it's going to be drawing in a whole list object. So let's take a look at what this actually looks like. So our bag of words 0 here, and let's also grab in our shape as well. So let me go in and print bag of words 0 dot shape. And so what this is going to go is that there are going to be how many unique words here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 unique words in this instance, okay? So notice all of them only appear once. Let's grab, I want to grab another example where we have more than just ones. So this is actually very, very relatively unique. Let's look at one. What was one? 2. maybe we can just do 2. So I'm going to go on and put, I'm just going to overwrite this. I know it's frowned upon, but it'll be fine right now. And so here you can actually see that there are, again, there's probably 20 unique words here, but there are 2 instances where there are multiple counts of a word. Okay, again, this is just an example to see. So we can actually go through, and for example, we want to see these words that were mentioned twice. Okay, so we can grab that little codec here, that index, and so we can go and do something like we want to see what our CV transformer. We want to get feature names, and then we can actually just put this. Whoops, we want to put this in to do our bracket notation. And so that one was FA. Again, I don't know what FA Cup final, so maybe some sort of soccer World Cup. And what's the other one that had 2? So 6,331 entry. So again, maybe they're looking for entries into some World Cup. So that's a very interesting way to check that out. Now, another thing that we can do is we can use our transform object for this bag of words, okay, on the entire data set. So let's go on and actually do that. So let's do text messages bag of words here, and we'll do our count vector transform on it, and we are going to do this on all of the words. So again, this again may take a little bit of time. So I'm going to go on and we'll look at creating up a piece of code here that will take a look at it. So we want the shape of the sparse matrix in here, and this one, I want this to be an F string, and we're going to do our text messages bag of words dot shape. Whoops. And we also will do something like print F string here, amount of non-zero occurrences. And so what this means here is that it'll actually count out how many times that there was a non-zero component. So we have where there's an actual word that's available to us. And we'll do here is text messages bag of words dot nnz. So that means for our non-zero instances. So again, here we see that our sparse matrix is 5,572 long by 11,425 wide. We have 50,548 non-zero occurrences. So we can also go through and measure up here the sparsity. So let's do something like, again, so sparsity, let me actually go through and actually do this. So messages, not messages, we have our text messages bag of words, and we want our dot nnz. Okay, so our non-zero occurrences divided out by our messages, our text messages shapes. Okay, and so it's going to be the shapes multiplied by each other. So how many observations we actually have, and so this is multiplied by 0, and then we also have our text messages shape here, whoops, what didn't it like? Oh, whoops, here, dot shape. So, okay, and I need to multiply this out because this is actually really small, but the sparsity of this is basically 0. Okay, so even if we multiplied this out by 100, I'm going to label this sparsity. And so then you could do something like print So this would be our sparsity. Again, it's close to 0, but not quite. So we also need to probably take into consideration again. So we've done some normalizing, that type of stuff. What's going to be next for us is going to be our term frequency inverse document frequency. So our TF-IDF. And so this is actually very important for us and what we're going to be doing a lot of the time. So let's actually do this and talk about this in a way. So consider we have something that has like 100 words where the word apple is going to appear maybe 3 times. Okay. Well, then the term frequency of that. Okay. So if we have, let me actually write this out here. So example, we have 100 words, okay, and we have, I don't know, maybe actually let's do this as a banking example. So maybe the word bank is mentioned 5 times. Okay, now since it's mentioned 5 times, the term frequency, okay, is going to be our 5 divided by 100, okay, and so let's do this as 0.05. Now, if we assume, for example, that we have maybe I don't know, 1 million, or maybe even 100 million documents, okay, or 10 million documents, it doesn't matter, and with the word that appears maybe with the word bank, so let's say assume 1 million, capital M, documents. Okay, and so in the word in there, okay, so bank appears, let's say we have it as, I don't know, 1,000 times. Okay, so what are we going to do with this? Well, we need to also have the inverse document frequency in here, and that would be, here is log of that 1 million, okay, divided by that 1,000 times, okay, and so actually let's maybe see what that would be here real quick. So mp.log here, and we have million divided by 1,000 in here, and so that's 6 point, so let's say it's going to approximately going to be 7. Okay, so what we actually would do here is to calculate our TF-IDF, okay, that would be our term frequency multiplied by our IDF. So we can actually do that in here. So multiplied by 0.05. Okay, and that'll give us point is equal to 0. Let's just say 35. So this is our inverse document frequency, and so this is actually telling us some words, okay, aren't going to be as important, because again, if it physically manifests a lot in a document, it's not necessarily going to be, it's not going to have a lot of information in it. Now, it may be the topic itself, okay, so the term frequency is important to tell us maybe the topic, but when we talk about the important words that are unique to the data set, that's where we need to calculate up this inverse document frequency to help kind of weed out those very common words. So let's go on and use Scikit-Learn to actually calculate this up for our data set. So from sklearn .feature extraction .text, we want to import the TF-IDF transformer. So let's do TF-IDF transformer in here. And we're just going to fit this on our data. And which one are we going to do this on? Let's do this on our bag of words already. And then let's actually take a look at, we need to transform this for a specific one. I think I used, so bow 0. All right, so let's do TF-IDF 0 is going to be equal to our TF-IDF transformer transform, and we want that on our bow 0. Is what we had before. And so let's take a look at the TF-IDF 0. Whoops. There we go. So you can see here that now we have the inverse document frequency for each of those words for this particular text message. So let's see. What are some of the high numbers? And here is this one. And again, this is for the entire document, how it would compare for the entire document. Again, so here we have a really high number in here. All right, remember, go back to here, we see that the term frequencies here, this was high, okay? This one was high, and this one was high. Okay, and I think this one was FA, and this one was entry. So then we would expect that those numbers are going to be high as well. So look here, this one's 3.47, so 3.5. This one here has a high number as well. So those have a relatively high term frequency. They're common. So then if we look at the uncommon words, let's look for something with a 0. Okay, so this is our 0 here. This is a lower level number. So let's look and see what this one is. This one may have a lot of information, or it may actually be completely useless to us. So let's actually go through and actually look at what that word is. I'm going to go and copy the code from up here really quickly so we can actually see that word. And it was 423. 2. Okay, so it's actually a number. So again, maybe it's important that inside of this text, so maybe they're looking for 2 entries, okay, for that FA, whatever the FA was. But again, that's maybe necessarily taking it out of context. So let's maybe go ahead and look at, for example, some of the term document frequencies for some other words if we want to. You can look them up by a specific word if you want. So let's do something like print TF-IDF our transformer dot transform here, and we're going to do this on our you know what? We want to check by a specific word. So we do IDF underscore here, and then we do our bag of word. What was that? What was our vocabulary? What did I call the? Oh, there it is. Text message bag of words dot vocabulary underscore. And we want this for, let's try you. Oh. Where did it go? Okay, the transformer. Transformer vocabulary. All right, sorry about that. I'm having trouble remembering what I actually wrote down. That's a problem, isn't it? All right. So okay. So one thing that this won't work is because you, for example, is going to be a stop word. Okay, so it will not be in there. We will get something weird. So let's try universe, nothing. Well, let's go up to a print here. All right, let's do think. Okay, so this is the term frequency of think. Okay, so again, you can go on and you can look up words individually, and again, we can always convert the entire text TF-IDF for the entire thing, for the entire data set. So we do the transform here, and we'll do this on our text messages for the whole thing. And then we can actually look at the shape real quick so you can see how big this gets. One thing is, again, make sure that you have enough RAM whenever you are starting to mess around with this stuff. Again, this is just a toy data set of text messages. If you start looking at big documents or anything else, you're going to need a lot of memory and a lot of computing power to run this. So here we have, it's 5,572 over 11,425. So again, there are going to be a lot of ways in order to do this. Another way, for example, is to use pipelines. In some of my other examples, we will go through and we'll use pipelines. Probably the next video we will go about doing that. And actually, let me end this here for this part, and I will continue up a next part here where we actually train a naive Bayes model, and we'll actually go on and use a pipeline in the next video. So if you guys like this, please comment, subscribe, and hit that like button, and I will see you guys next time. Bye-bye.